Hello everyone, my dear friends. How are you all? This is your educator Ayush Jain and I am presently pursuing B in Mechanical Engineering from IIT Indore. So guys, I have got this course for all of you, basically for class 10th Science chapter number 9, chapter number 10, class 10th Science chapter number 10, which is basically light. In this course, I will be discussing in detail about this chapter, and it will be a huge comprehensive course for all the competitive examination that you are going to appear for, like NTSC, NSCJS, etc, etc. Okay, this course is valid for all the competitive examination, and this is going to be a huge comprehensive course. Basically, what I will be doing, I will just change the content of 10 hours to just 4 hours. Okay, 10 hours of 10 hours of knowledge you will be getting in 4 hours, because all these things are printed as it is everything is printed over here, so that time duration can just reduce. And also this similar course is also present in Hindi language. Okay, so if you are having any trouble in understanding English, you can go and prefer those Hindi lectures. Okay, no problem in that, but it will be a huge comprehensive course in both the languages. Okay, so guys, basic introduction of myself. I cleared JEE Mains examination, IIT JEE Mains examination in 2018, and I am presently pursuing BE in Mechanical Engineering from IIT Indore. I was a I was an Unacademy Plus educator previously, after which I just left Unacademy Plus because I wanted to teach all of you, that too basically for free. Okay, I want to teach, I want to deliver the best knowledge for free. Okay, that's why I left Unacademy Plus also, which is basically the India's largest platform. So I was an educator over there also. So without wasting time, let us just start with this chapter named as light. Now, the first question which comes in our mind, what is light? So guys, that bulb is hanging over me. What is that? That is a source of light. Okay, the sun. What is it? Is it also a source of light? Yes, it is also a source of light. Then stars are also the source of light. Yes, stars are also the source of light. Moon also produces light. It is also a source of light. Yes, this, if I say that this box of pen is also a source of light, then will you agree? Yes, this is also a source of light. I will tell you why this is a source of light. Okay, if I say that this pen is also a source of light, will you accept it? Yes, you have to accept it, because I will be telling you how this pen is also a source of light. Okay, means everything that we can see around us, all around us, that is basically a source of light. As simple as that. Okay, so if we just want to give a proper definition of source of light, what is it? A source, a light. What is light? Light is basically electromagnetic energy that causes a sensation of vision. Okay, anything that is causing a sensation of vision is called as light. Now here I have written it as energy. So energies of various types, like what all type? Like kinetic energy, potential energy, nuclear energy, vibrational energy, molecular energy, light energy, heat energy, and various other types. Okay, so light is also a form of energy. Keep this in mind. Light, the unit of light is also joules. No problem there. Okay, so I hope you have understood what light is. Now let us move further on this particular topic. The second thing that we have to understand is what is optics. Basically, whatever you are studying about light comes under the topic named as optics. But what I have written over here, light ki padhai, this is known as optics. Yes, what is optics? Optics is the science in which we are basically dealing with the behavior of light. Okay, that is known as optics. Now this optics is again divided into three parts. Okay, this optics is again divided into three parts. What are these three parts? These three parts are geometrical optics, wave optics, and quantum optics. What do we mean by geometrical optics? Geometrical optics is basically the branch of optics in which we are treating light as showing a particle nature, or light as traveling in a straight line. Okay, if we consider light to be traveling in a straight line, that all thing, and we are just tracing the behavior of light, considering it as a ray. Okay, if we are just tracing the path of light, considering it as a ray, then this thing comes under geometrical optics. Okay, So whatever we are going to study in this particular chapter, we are going to study only about geometrical optics. Okay, then what about wave optics and quantum optics? All these things you are going to study in 12th standard, or if you are going to pursue IIT examination, or if you are going to pursue under NEET examination, over there also you will study this thing, about this thing about wave optics and quantum optics. But I will be briefing you about what is wave optics and what is quantum optics. Now, this thing, okay, I think I will tell you about this thing in my further slide. But geometrical optics is what? The branch of physics in which we are going to consider the light, the path of light as traveling like a ray, and that too a straight line. If we are just dealing with this kind of behavior, that comes under the geometrical optics. If we are treating light, okay, if we are just treating light as wave, but how come we can treat light as a wave? Yes, we don't know it. We You can say that we can't consider light as wave, but just tell me, if we are dealing with geometrical optics, it means light is traveling in the form of a ray, means light is traveling in a straight line. But for the light to travel, what do we need? If there are particles present, okay, if there are particles present, then only the light will travel. But we have seen what? We have seen that light travels in vacuum also. But how come when particles are needed, vacuum has no particles present in it, then how come light can travel in vacuum also? How is it possible? Is it possible? It is possible because of this branch of physics, this branch of optics, which is known as wave optics. Okay, what is this wave optics? Wave optics basically tells us about the behavior of light, another sort of behavior of light, like interference. What is this interference first of all? So it tells us about interference of light. Interference, I can just simplify this language because it is basically a high level concept, but I am telling you just the basic thing. The basic interference, the basic thing is what? The basic thing is this, that suppose there are two sources, right? Okay, suppose this is red light, which has shown as source number 1, and suppose there is another source of light which I am showing it as blue light. Okay, suppose this is another source of light which is S2. Okay, now what I am doing, this light is traveling. Okay, suppose we consider that this light will travel in a straight line. Okay, suppose we are considering that this light travels in a straight line, and the other light also travels in a straight line. Okay, suppose we are just considering this light also travels in a straight line. But how is it then, how is it happening that when we go in discourse and all, what we see when we go to EDM nights or any other thing, what we see that they both lights combine up. Okay, these both lights are combining up something like this. Can I say it, that they combine up something like this? Suppose, and for red light, means there is a region in which both color lights are present. Okay, there is a region, suppose this is the region where both color lights are present. But in geometrical optics, we were told that light is traveling in a straight line. Then how come this is possible? This was also explained with the help of wave optics, that light travels in the form of waves. Okay, I think it is clear to you. Now, the third branch of optics. Okay, the third branch of optics. Basically, what we do, we just consider geometrical optics also. We just consider wave optics also, because in some parts, wave optics was not able to tell why this kind of behavior light is showing, and in some parts geometrical optics was not able to tell why light is showing this kind of behavior, like interference, diffraction, polarization, etc, etc. Okay, so this geometrical optics was not able to tell something, wave optics was not able to tell. That's why we are just considering that light shows both these behaviors. Okay, so light shows both the behaviors. Light shows first behavior and second behavior, both the behaviors light is showing. Now, what is this third one? Okay, what do we mean by quantum optics? Now, suppose what we are doing, we are having a metal piece. Suppose this is a metal piece. Okay, you can consider it as a metal piece of cesium or potassium or any other metal. Okay, what we are doing now, We are basically taking the source of light and we are passing light on this particular medium with a higher frequency or high intensity. We are passing a high intensity light on this particular medium, and what are they? They are cesium atoms, there are potassium atoms or any other kind of atoms. Okay, so atoms are present over here. Now what will happen when we are passing a very high a light with very much high intensity? What will happen? Some of the electrons will get separated from it. Okay, some of the electrons will get separated from it, and what will happen? Suppose this is one electron, this is another electron, this is another electron, and this is another electron. So electrons are getting separated from it, and what will happen? They all these electrons will form packets. Okay, all these electrons are forming packets and they are traveling combinedly. These packets are known basically as photons. Not to go in much depth in this particular topic, but I am just introducing about what is wave optics, what is quantum optics. We don't have to go in depth in this particular topic. Okay, so what are these? These are basically photons. Okay, so they are basically traveling in the form of photons, and only this thing. Okay, about all these. Now moving ahead, what we are seeing, we are going to look towards the theories about nature of light. Basically, what are the theories? Whatever we have done over here, geometrical optics, wave optics, quantum optics, these were given in the form of theories. Okay, so first theory is named as Newton corpuscular theory, which was given by whom? Array, it is written. Yes, it is written that the Newton's corpuscular theory was basically given by Newton. What was written in this particular theory? In this particular theory, Newton told that light is traveling in the form of particles. Means there must be particles present for the light to travel, and the light is traveling basically in straight line. This was told by Newton, and there was nobody to question Newton because Newton was Newton. Yes, he was basically a great man, so no one came to question him. Though many were knowing that this is not possible, these are another cases, how come this case is occurring, but no one was able to tell this to Newton. Okay, but and Newton was a great man. He was not even listening to others what they were trying to tell. Okay, but after the death of Newton, okay, after the death of Newton, Schrodinger, Young, Huygens, and many other scientists came, and they told about the wave theory of light, which was introduced because of what? Which was introduced because of this interference, diffraction, and polarization. Okay, I can just write these names over here so that you remember: interference, diffraction, and the third one is named as polarization. Okay, so these phenomena were basically shown by the wave nature of light, which was given under wave theory of light. And the third one is polarization. Okay, so I think this thing is clear to you. Now what is this quantum theory of light? Only this theory which I told you over here. That's why I was telling that I should tell it further, but I told it over here. This is known the branch of science in which we are dealing with this particular thing about passing high intensity light to a metal piece, and the electrons get separated from this that metal piece that is known as quantum theory of light. Okay, as simple as that. Now moving ahead, what we have to study? We have to study about the source of light. Okay, so there are basically various sources of light. There are basically two sources of light. What are the source of light? First source of light is that source of light which is basically producing light by itself. It is not needing any other thing to produce light, like the sun, like the stars, like the lamp which is present over here, like the tube light which is present over my head. Okay, they are producing light of their own. Okay, so any object which by itself emits light, like sun, stars, bulb, all these are what? These all are basically the luminous source of light. Okay, they all are basically the luminous sources of light. Okay, now another category is basically non-luminous source of light. If we are dealing with any object which emits light of their own in luminous sources, then what we are going to deal with in non-luminous sources? Those objects which take light from others. Is it so? Yes, it is so. Okay, the objects which are taking light of others and then glowing, they are known as non-luminous sources. Light, like this pen box, this box of the pen, what is it? Is it visible to you? Yes, it is visible to you. But how come it is visible? Because of the light which is glowing over my head. Yes, if that light was not present, if I just switch off that particular light, then will it be visible? No, it will not be visible, because it is taking light from that light which is above me. That's why it is visible, and that's why it is known as what? It is known as non-luminous source of light. Okay, so objects which do not emit light but becomes visible only when light from luminous objects fall on them, they are basically known as non-luminous source of light. For example, chair, desk, this box, this pen box, this tube which is in front of me, this whiteboard which is over there, me myself, I am also non-luminous source of light. Okay, so all these are non-luminous source of light. Let us move further. Now we are going to talk about the medium of light. There are basically three mediums of light which are present for us. Okay, what are the three mediums of light? The three mediums of light are basically transparent medium, translucent medium, and the third one is opaque medium. What is a transparent medium? Okay, suppose that you are standing over here. In front of you, there is air all around. Can you see the objects which are present behind you? Sorry, can you see the objects which are present in front of you? Yes, I can easily see all of these. If there was a glass, okay, if there was a glass, then too can you see the objects which are present in front of you? Yes, you can see all the objects clearly, and that too, there is no blurred vision. You can see all the things clearly. Those all objects are known as transparent objects, and that medium is known as transparent medium of light. Examples of transparent medium of light, as I told you, glass, water, air, etc. All these mediums of light, they are known as transparent medium of light. Okay. So what is happening basically in transparent medium? Suppose that this is a transparent medium. Okay. Suppose that this is a transparent medium. What you are doing? You are providing light from here, from here. Okay. What will happen? Light will pass completely through the transparent medium, and the light completely will go over here. There is not at all a single. There is no absorption of light in the medium. Okay, there is no absorption of light in the medium. The complete light is passing through this particular medium without getting absorbed in that medium. Okay, so that medium is basically known as the transparent medium. The second medium is known as the translucent medium. What is it now? In translucent medium, what we look towards? Some part of the light gets absorbed. Okay, like suppose there is a translucent medium in front of me. Then in that medium, some of the light gets absorbed and some of the light gets reflected. Means some of the lights travel above and some gets absorbed. Like suppose that there is a translucent medium. Okay, suppose that there is a translucent medium. Now what you are doing? You are passing light from this side. You are passing light from this side. What happens? Suppose the light which you are passing is of, you can consider 120 joules. Okay, suppose you are passing light of 120 joules. You can consider that 20 joules of light gets absorbed in it. Okay, 20 joules of light is getting absorbed in it, or maybe 50. You can consider any figure. It's just an example. Okay, and what is happening to the some of the light is passing through it, but some is also absorbing it. Okay, some is also absorbing it. Here 100 joules of light pass through it, and because some of the light is getting absorbed in it, it is known as translucent medium. What happens in a translucent medium? Basically, because some of the light is absorbing, there is a blurry vision when you see the objects which are present in front of you. Okay, when there is a translucent medium in between. Okay, so there is a blurry vision, and this blurry vision is because of this translucent medium, because the light is getting some of the part of light is getting absorbed in it. So what? Let us just read the definition. So translucent medium is something which transmits only a part of light to them. Okay, some part is transmitted and some part is getting absorbed. For example, frosted or ground glass, grease paper, paraffin wax, all these are the translucent mediums. Okay, so let us move to the third type, that is known as opaque medium. Yes, I have the objects to show you the opaque medium. Suppose this is the box of a pen and my hand is present behind it. Okay, suppose this is the box of the pen and my hand is present behind it. Can you see my hand? Is it possible that you see my hand? No, it is not at all possible, because what is this box? This box is not at all, this box is not at all transmitting any energy from the other side. Okay, means that suppose if I draw the figure, what is happening? Means that suppose this is an opaque object. If I am producing some of the incident light on this particular thing, then none of the light is passing from this particular thing. Okay, suppose that 100 joules of light was produced, then 100 joules get absorbed. Okay, 100 joules of light is getting absorbed, and no light is producing after this. Okay, no light is producing behind this. That medium is known as opaque medium. Okay, so opaque medium do not allow light to pass through them. Okay, what is an opaque medium? Opaque medium does not allow any light to pass through them. For example, chair, desk, this box, this thing which is present with me, this pen or this board, this is also an opaque medium. Okay, all these things are opaque medium. Now let us just move ahead. We are going to look towards the rectilinear propagation of light. What is this rectilinear propagation of light? If we are saying rectilinear propagation of light, it basically tells us that light is traveling basically in a straight line. Okay, light travels from a source in a straight line. Light is always traveling in a straight line, and you can relate it with Newton's corpuscular theory also, no problem with that. Okay, this was basically told by Newton in his Newton's corpuscular theory, and we have to just study that particular theory. Now light is traveling just in a straight line, and if we consider light to travel in a vacuum or in air, then the speed of light is basically 3 into 10 to the power 8 meter per second. This figure you have to remember to solve various numericals coming not only in this chapter but in various other chapters also. This is the fundamental thing, that the speed of the light in air or in vacuum is basically approximately 3 into 10 to the power 8 meter per second. This thing you have to remember. Okay, so let us just move ahead. What is the behavior of light at the interface of two media? I think this is a last topic for this particular day. Now if we just take first medium you can consider it as air. Okay, so air is the first medium, and the second medium that we are considering is basically you can consider it as glass. Okay, so air and the glass are two mediums. Now if you are just producing light like this, okay, light is being produced from this particular path, then what will happen to light? Light will have three main things. Okay, light will have three main things to do. First thing is basically known as reflection. Okay, means some part of the light will travel in the same medium but with a change in direction. Okay, means the light was coming from this particular side, now the light is traveling in the same medium. It is not going inside the other medium, but it is traveling in the same medium but with change in direction. Now because the light is traveling in the same medium, this thing is known as reflection. Okay, this thing is known as reflection. The second thing is basically known as the refraction, in which the light is incident on the second medium, and it gets inside the other medium with the change in direction. Okay, the direction changing. If the light was traveling without any reflection, the light might have traveled something like this, but it is not traveling like this. It is changing its direction, because there is a difference in this is another medium with a different refractive index. I will tell you about the refractive index, no, not to worry. Okay, because of the change in refractive index, the refractive index of air is something, the refractive index of glass is something else, and because of this refractive index, the light is getting deflected. Okay, now the third thing that I cannot show over here is basically absorption. Some part of light is getting absorbed also in this particular medium. Okay, which we cannot show, but we can write something like this, that suppose the energy of light at this particular point was basically 500 joules. Okay, for example, the energy of light was basically 500 joules. When the light passes from this particular medium again in the same medium, the energy might become 300 joules. Okay, so there is a change in energy by 200. Where is this 200 joules energy gone? It is gone under absorption. Okay, it is gone under absorption. Or suppose you consider that 300 joules over here, 100 joules over here. Where is the 100 joules energy gone? 100 joules energy is gone under absorption. Okay, it is getting absorbed in this glass medium. As simple as that. Okay, so now just look towards the definition. First thing, the part of incident light turned back to the first medium is known as reflection. As we have seen over here, this is the first part. The light is getting reflected. Okay, part of incident light turned back into the first medium. It is present. It was going to the first medium only, and it got back again in the first medium only. Okay. Second thing, part of incident light which light transmitted to the second medium along with the change in direction, it is known as what? It is known as refraction, which we have discussed over here. This thing is basically known as the refraction. Third thing, for the another part is basically getting absorbed in the second medium. Yes, some part is getting absorbed in this glass slab, so that comes under the absorption. Okay, so I think only this much for this particular lecture. In the other video, okay, in the second video that I will be creating, over there I will be discussing about the reflection of light. Okay, I will be discussing in complete detail about the reflection of light. So please stay tuned. See ya, take care, meet you in the next one, and till then take care and bye bye.